Hi everyone. In this lecture video, we are going to discuss about initial basic feasible solution of transportation problem by Nourth West Corner rule and the least cost method. First, we discuss initial basic feasible solutions in a transportation problem by Nourth West Corner rule. So now we have one problem. Consider the given one. Determine basic feasible solution to the following transportation problem using Nourth West Corner rule. Here there are the supply side PQR and demand A, B, C, D, E, and the unit cost are 2, 11, 10, 3, 7. And the next one is the Q side 1, 4, 7 to 1, and the R is 3, 9, 4, 8, 12. Corresponding supply for P is 4, Q supply has 8, R supply is 9. And the demand side, A demand is 3, B demand is 3, C demand is 4, D demand is 5, and E demand is 6. This everything is given. We find the initial transportation cost for this given transportation problem. So first we check whether the given transportation problem is balanced or unbalanced. If it is so, we attain the feasible solutions. That is, total supply is equal to total demand if both are equal or not. Here the total supply is 12 plus 9, 21. Total demand 3 plus 3 plus 4 plus 5 plus 6, that is 21. So total supply and the total demand both are 21. Therefore the given transportation problem is balanced. Therefore there exists a feasible solutions. Now we apply the Nourth West Corner rule. We find the initial transportation cost and initial basic feasible solution also. Here first we check the Nourth West Corner cell in this one, that is minimum of A1, B1. So in this cell we get a minimum of 4 and 3, that is equal to 3. So first we choose the Nourth West Corner cell. The first cell, the unit cost is 2 and its corresponding supply 4 and the demand is 3. From these two, there are 3 demand and 4 supplies available. From that 4 supplies we fill the demand. So we pass 3 items from that cell 1, 1. So 3 items are passed. Then we fill the demand. After getting, we get 1 supplies available. So in this side there is no demand in the first column, therefore block the cells. Then we choose the remaining. We apply the Nourth West Corner here. The cell 1, 2 and its corresponding supply is 1 and the demand is 2, 3. So we pause the 1 supply and fill the demand, 3 demands. After getting that, we get 2 demand is also there, and in this first row we have no supplies available, therefore block the remaining cells. Next we choose the Nourth West Corner, that is the cells 2, 2. There are 4 unit cost. Its corresponding supply 8 is available and the demand is 2. So from that 8 we take 2 and fill the demand. So there are 2 supplies are passed, transferred and with unit cost of 4. So from that we get no demand in that second column. So after transfer that, out of that 8 supplies, 2 is distributed, therefore 6 supplies available. Then again apply the Nourth West. We choose the cell 2, 3 and its corresponding supply is 6. Demand is 4. So from that 6 we fill all the demand with unit cost 7, and then we get 2 supplies available and there is no demand. From that third column there is no demand, therefore block the remaining cells. And next apply the Nourth West Corner. We choose a cell 2, 4 and its corresponding supply is 2, demand is 5. So from the 2 you just fill the demand 5. There are 3 demand is closed and 2 supplies is first transferred with unit cost of 2. After that we get no supplies available from the second row, therefore block the remaining, and still we have 3 demand is also there, and one more 6 demand is also in this demand side. So totally 9 demand is there, but in the third column we have 9 supplies are available. So split this 9 with 3 and 6 and fill all the demands. Then it is called the rim satisfaction. So from that we get the initial feasible solutions, that is 2 in first row, first column, that is x11, it is 3, and x12 is 1, x22 is 2, x23 is 4, x24 is 4, x34 is 3, x35 is 6. These are all basic feasible solution. Then m plus n minus 1. So m plus n minus 1, m is number of rows and n is number of columns. Here there are 3 rows and 5 columns. So 3 plus 5 minus 1 is equal to 7. And the number of basic cells or occupied cells is also 7. So these two are equal. Therefore we get a non-degenerate basic solutions. So what is the transportation cost? So we had in the first cell 2 into 3, in second cell 11 into 1, because it is a unit cost, and in the second row, second column 4 into 2, second row, third column 7 into 4, second row, fourth column 2 into 2, and third row, fourth column 8 into 3, third row, fourth column 12 into 6. Total we get 153. That is initial transportation cost. Next we have we find the initial transportation cost using by least cost method, or initial basic feasible solution using by the least cost method. Here the problems are given, the supplies and demand. First we check it the totals, if whether the total supply and demand are equal or not. So total supply is 100, demand is also 100, therefore the given problem is balanced. If it is balanced, we get a basic feasible solution. So there exists a basic feasible solutions. Now we find that solution using by the least cost method. So what is least cost method? Among these all the cost, we choose the minimum cost. So here in this all the unit cost, the first row, first column has a minimum cost 1. So you consider its corresponding supply and the demand is 30, 20. From the 30 we filled 20 demand. From that still we have 10 supplies available. Then we block the first column. Then we have the second one. So 214, 321, 259 is the unit cost of the TP. From that apply the least cost. So least cost is here in the second row, in the second table, the least cost is 1, that is first row 1. So its corresponding supply 10, demand 40. So take all the demand 40. So take all the 30 supplies and fill the demand. Already we filled that. So 10 supplies available and 30 demand is there. So take that 10 and fill that 30 demand. Still we have 20 demand is also there. From that supply side there is no supplies available in the first row, so block the remaining. So then that we have the remaining cells is 321, 259. So here the least cost is 1. Apply the least cost method, that is least cost is 1. This corresponding supply is 50, demand is 10. So take 50, take 10 item from that 50 and fill that 10 also. Still we have 40 supplies available. Then block that corresponding column. Then finally we have the only the cost cells 3 to 5. So here we choose a minimum. So in this the minimum is 2. Its corresponding supply is 40, demand is 20. So from that 40 we take 20 demand filled. Then we have only 10 supplies available. And finally we have this 3 2. 20 is there. So take all the 20s and fill the 40 demand. So we have the rim satisfaction also. So here the number of basic cells are 6, because the m plus 1 minus 1 is 3 plus 4 minus 1, that is 6. So both are equal, therefore non-degenerate transportation, non-degenerate solutions. And what is initial transportation cost? 1 into 20 plus 1 into 10 plus 3 into 20 plus 2 into 20 plus 1 into 10 plus 2 into 20, that is equal to 180. Thank you.